Okay, so it's me again. Sorry about that. The next presentation is going to be about something that I feel is a fundamental change in how we are going to approach testing over the next 10 years. And it's already emerging. Lots of organizations are already starting to do this kind of testing. So I'd like to motivate you to start thinking about this if you're not already doing it. And if you are doing it, maybe give you some new ideas and some tools to think about how to do it better. And I'm going to talk about testing in production. So 10 years ago, testing in production was a derogatory term. It was something to kind of explain how a team is bad. We'd say, oh, they're testing in production. Their users are finding bugs and it's exploding all the time. But testing in production today is one of the best techniques you can start implementing if your architecture is evolving and going to the cloud. 15 years ago, most organizations were controlling the infrastructure on which their software was executing and pretty much the devices that their clients were executing on as well. Then about 10 years ago, with the surge of mobile phones and platforms that started kind of evolving, we stopped controlling the infrastructure that our clients are executing on. About 2 years ago, we had a bug report from somebody who tried to run our web application on a Samsung refrigerator and then complained that it doesn't work. And the more we are moving to the more organizations are moving to the cloud, we are losing control over the infrastructure that the app is executing on as well on the server. So now we don't control any of that. And the big question becomes, is the test environment even relevant anymore? And IDG, the American analytics company, published a survey on cloud adoption, and they talk about how 77% of enterprises globally have at least one application running in the cloud. And that's increasing and increasing, and how 60% of all kind of IT infrastructure spending and about 60 to 70% of all spending on software in about 2 years' time is going to be for cloud infrastructure and cloud applications. Forrester published a similar research a year ago talking about how about 60% of enterprise workloads in the US are now running on the cloud. So this is a trend that is happening to everybody. And with this, we are no longer in control of how we run, but more importantly, deploying on the cloud is not just a way to save on infrastructure, it's a way to use a whole network of services that are already available there. What's happening now with AWS, with Google and Azure is they're actually turning the whole thing into an API marketplace. If you're deploying on AWS or on Google, you have databases there, but you also have authentication, you also have logging, you also have security modules, you also have billing, and all of these things make it really, really quick to deploy a new application. Most of the infrastructure development is already done. But with that come a completely different series of risks. For example, I was traveling to speak at a conference in Spain about 2 years ago, and I was flying through France. So I was going to stop in Paris, and I timed it just right to get off the plane in Paris, get onto the train, go to the center of the city, eat a really, really nice steak, then get a kind of train, go back and catch my flight. And when I landed in Paris, I started my phone and I got a couple of thousand emails that our system's exploding and everything's wrong. And so, I didn't get to go to the restaurant. I ended up trying to troubleshoot the app from a bad airport Wi-Fi. But at the end, what had happened is Google decided to change the order of events happening when people authenticate. And we had lots of people signing in through Google because we were using the APIs. And they were sending a session event before they were sending a kind of a confirmation of authentication. So we were just discarding those things and people couldn't log in anymore. Now, the big problem with kind of deploying to the cloud is that major risks happen after deployment. There's a huge amount of risks that happen even if you don't change your code, because most of the benefit in the cloud now is actually using all these APIs that are not under our control anymore. So the fact that I've tested my application before deploying and I've proven that it works doesn't mean that it will keep working. And a huge amount of risk actually happens traditionally at the time where nobody tests anymore because we've tested it. And I think kind of those two trends are going to cause more and more people to need to start thinking a lot more about testing after deployment. So kind of there's a brilliant example of that happened in 2014 in England, just before the Christmas sales. So there was a pricing application called Repricer Express that would adjust automatically prices of things people were selling on the Amazon marketplace. This was designed so that you make the most amount of money. And it was one API using another API, using another API, using another API. And this is how the applications are built now. And this application was used by lots and lots of small shops in England to sell things on Amazon and to offer deals. On the 12th of December 2014, during busy holiday sales, one of the APIs decided that the best way to increase sales is to reduce the prices of everything to 0.01 pounds. It created lots and lots of sales. It was amazing. The problem with APIs connected to APIs connected to APIs is that the whole chain is automated now. So when people started buying like crazy, they were buying new iPhones for 1 penny. They were buying vacuum cleaners, and they were buying kind of lawnmower machines for 1 penny. And all of these things, because they were already in Amazon warehouse, they're all connected with the APIs, kind of pretty much they were sent out before anybody noticed any problems. The problem lasted only for about 10 hours, but kind of people lost a huge amount of money on this. Now, this kind of testing is really, really difficult to do because there's so many components that do not depend on us anymore. And although we cannot predict unknowns like that, the major thing we can do is spot these things before everything is kind of gone, before all the iPhones are delivered and before people lose so much money. So the key part of testing in production needs to be spotting these unknowns. And this is where a lot of kind of what testers need to do turns into monitoring. We don't even know what we're looking for. These are unknown unknowns, but we need to be able to monitor them. So here's a couple of interesting things that we can start monitoring for so that we can start noticing unknowns. One of the best things we can start monitoring here is we can start monitoring for behavior changes. Behavior changes, unexpected changes of users' behavior tend to point out to something unexpected happening. If all of a sudden we are making 10 times more sales per minute than we used to do, that's interesting. We might be making a lot more money, or there might be something horribly wrong going on. And we need to be able to understand and monitor and look for these behavior changes to be able to kind of see what happens. And monitoring for behavior changes is actually quite an interesting technique to start optimizing the rest of the testing that we need to do. For the Spec by Example book, when I was writing that, I interviewed a company that is a price comparison engine in the UK, where one of their biggest problems was the speed of automated tests. Their automated tests took a couple of days to complete, and this was slowing them down. And they were challenging whether there's any sense running all those tests all the time. And part of what they started thinking about is tests are good the first time when they pass because they've proven that you've done something, you kind of execute. But does it make sense to keep running them for the next 2 years? Can we spot problems differently? And what they started doing is they started thinking about trends of their user behavior. They started capturing trends of their user behavior and noticing periodic patterns. What happens on Monday, what happens on afternoons, what happens in January, what happens in September. And then they could compare, is this normal behavior on the website or not? Do we have people opening more pages or fewer pages? And as a result of that, they started disabling the tests, automated tests for the things that are not changing. So they were able to kind of protect the quality and significantly reduce the time it takes to run automated tests, because kind of they even started deleting the tests that have not been executed for a while. They realized there's a lot of value running the test the first few times, but then kind of if you monitor for behavior trends, you actually don't have to do a lot of these things, as long as the changes are small. So as they were releasing very, very small changes, they were getting small problems and fixing them. So another really interesting thing to start thinking about there is not just monitoring, but also using behavior changes as acceptance criteria for what you want to achieve. There's a really great story from Google. You can find lots of information on this story if you search online for 40 shades of blue. This is where about 6 or 7 years ago, the head of design at Google wanted to change the color of the links on the homepage. And they were looking at what is the acceptance criteria for this change, and he was saying how, okay, that when I look at the website, it's this color. But they actually kind of started, because they're monitoring for behavior changes actively, they started building behavior changes as part of acceptance criteria. So they said, okay, we do this color, how do you expect users' behavior to change? And he said, well, people will be clicking on more links. And as a result of kind of that, after the results came back, he decided to quit or he was fired, depending on whose side of story you read. And he wrote a really angry blog post called How You Cannot Do Good Design at Google. But kind of there was a conference in England later where people were talking about design, and somebody from the audience said, well, you're talking about how you do design, but Doug said that you can't do good design because you didn't accept his opinion about the color and things like that. And then they pulled the data, and because they measured the changes in behavior, they were able to prove that his color would actually lose about $250 million over a year. So, what is quality? Is quality matching the CSS color, or is quality making money or losing money? And now, if we start looking at behavior changes as acceptance criteria and actually testing for that in production, we can avoid lots and lots of silly problems. There's some really interesting data from Microsoft you can find if you Google for online experimentation at Microsoft, where somebody went back and actually compared how often do things that people propose in Microsoft as features deliver business value, actually deliver value. And his conclusion, Ron Kohavi, who wrote the paper, concluded that about 30% of the time, things they do actually move the numbers in the right direction. About 30% of the time, things they do not create any statistically relevant movement. And about 30% of the time, they actually damage the numbers they were supposed to improve. And in the paper, he also quotes data from Amazon, where he says that at Amazon, the success rate is slightly below 50%. What that means is that Microsoft is a good development company, Amazon is kind of great. If your company is anywhere on that scale, between good to great, about half to 2/3 of things you do match acceptance criteria in terms of this is what we were supposed to do, but they do not necessarily achieve business value. And testing for behavior changes is a really, really good way of figuring that out as well. So the second thing that kind of we should be investigating and looking for are client-side errors. The less we control the infrastructure on which the client software executes, the more you might get unexpected surprises. For example, for this collaboration tool I'm building now, we once stopped kind of having, nobody was saving documents using a Dropbox interface anymore. One day, no more Dropbox saves, which is really weird because we did not change anything in our code. But kind of we started investigating what's going on, and we couldn't even reproduce any problems on our end. And then we started kind of actually trying to figure out, is something unexpected happening in clients' browsers? And we put some logging to see, are clients getting exceptions when they try to access something? And we started noticing that all our requests to Dropbox, or a huge percentage of the requests to Dropbox, are actually being blocked on a network level. They were getting a network exception, so we didn't even know that it's kind of hitting us. And the reason for that is kind of some browser extension that started blocking requests to Dropbox because they thought it was advertising. Now, lots and lots of people are running these third-party modules that are interfering with your software anyway. You just don't know what's happening because there's so many of these different options. And if you just look at kind of cookie blocking, there was a research published by a company called eMarketer. You can find it at this link. They say that globally, about 22% of users are using some kind of an extension to block requests. Cookies, ads, privacy blockers, all these things are interfering with your application. They might be just blocking ads, or they might be blocking genuine requests, and you don't know about that. And because it's happening on the client, like, who knows? So in Germany, this is really, really kind of, they have data for Germany where it's kind of really high, where kind of, other countries are slightly lower, like France is 28%. They don't have any data for Russia. I was trying to find data for Russia, but they have kind of US at 25%. So, 1/4 to 1/3 of people that come to your website are using some crap software in their browser that's interfering with your app. And we don't even know what it is. So kind of one good way of trying to kind of do that, if you're using any kind of analytics, most analytics software has a way to kind of log exceptions as well. Google Analytics has a send exception, and you just give it an exception object, and then you can at least start noticing that people are having these exceptions in your kind of application through the analytics package. There's kind of lots of other systems as well. But usually kind of most people are not even tracking those errors. I did a research with JavaScript developers to poll them about how many people are even aware of these things, and about kind of more than half were not tracking any kind of client-side errors. They just don't know if the client-side application completely crashes or has problems or things like that. The only thing they have is server-side analytics for errors. 15% of the people are using web analytics like Google Analytics, but that kind of only allows you to spot trends. It only allows you to see that, okay, we have invalid pointer exception 1/3 of the cases, and it's rising, so let's investigate, or something like that. But there's a couple of other popular tools. Sentry is around 15%. Sentry is an amazing tool. If you're not using client-side errors, investigate it. It's on Sentry.io. About 15% of people use that. And kind of the next two most popular tools, according to my research, are kind of Track.js and Rollbar. So there's lots and lots of these things. What these things provide compared to just running analytics through Google Analytics is they allow you to spot a signal in the noise. People will have problems. We have people, as I mentioned, coming to a website from a Samsung fridge, or coming to a website from Internet Explorer, 6. And of course it's going to explode. It's not even supposed to work. So the fact that we're logging those errors, well, that's okay. But it's kind of the trends. It's the new types of errors. It's the new types of exceptions that are interesting. For me, one of the most interesting things to spot is there a new stack trace we've never seen before? Out of all these errors that are exploding, when a completely new stack trace appears, I want to know about that. I want to investigate. Or if we all of a sudden have, okay, it's perfectly fine to have login rejections. Some people will forget their password. Some people will enter a wrong password. That's normal, a percentage of them. But if a percentage of people entering a wrong password suddenly jumps and doubles, well, maybe there's something wrong in my software. And we need to know about these things. So these are the kind of tools that are not just web analytics, help you spot these things much easier. So the critical thing in client-side error tracking, I think, is separating out the signal from the noise. And that's why it's really important to kind of start investigating these additional tools. Now, the third thing that's useful to log are log anomalies. Log anomalies in a sense of system logs, network logs, stuff kind of that you produce, all applications produce some kind of logging. And usually logging is produced as a way for developers to kind of troubleshoot the app or to know what's happening inside, but that's a really incredibly useful way of peeking into the application. And if the logs start changing all of a sudden, that means that something unexpected happened. I mentioned earlier kind of where we had this, after changing this feature here, we started noticing 20 times more network requests. You know, that's a sign that something unexpected happened. And the big question is, are your system logs just a pile of data that, you know, disappears or goes somewhere, and people only look at it when there's a problem? Or can you actively spot logs changing in some unexpected way? And this is, again, where testers can play a really, really important role, because we can start investigating those things and figuring out what happened. So there's a couple of popular tools for log analysis that go beyond just kind of looking at text and searching these things, that can spot trends, that can spot new exceptions, that can kind of ignore timestamps and kind of figure out what part of the log is really important to compare. So that can save you a lot of time. The most popular tool on the market is called Splunk. The second most popular tool, I think, is kind of Graylog, and there's a Logstash, and there's a couple of these other things, but in order to make any of them work, what's really, really, really important is to start influencing the developers to approach logging as a first-order interface. Logging is a user interface. It's just not a user interface for end users using the system. It's a user interface for people trying to understand what's going on. And this is where we need to kind of start moving away from just let's dump anything we want in the logs. And a lot of kind of discussion, if you start approaching logs as a first-order interface, starts kind of around about, well, what is the structure of what's happening? What kind of data should we be outputting? And this is an incredible opportunity for testing as well. Usually kind of when we approach testing a system, we can only test, you know, if I do something here, does something over there happen or not? But if we define logs as something that's testable as well, then I can say if I do something here, I'm going to test the end result, but I'm also going to look at, did anything unexpected happen as an extra thing? How do you know that, you know, yes, a purchase goes through, but have you caused something else? And this is a brilliant, brilliant way to assist with exploratory testing as well. So approaching logging as a first-order interface helps us test in production, but it helps us also inspect and test the system much better while we're doing exploratory testing. We can kind of have like an X-ray vision of what is going on. And the more kind of applications go into the cloud, the more important this is going to become, because we are no longer in control of our infrastructure. There's an amazing story of somebody not doing that the way they should. That happened on the 1st August of 2012. A company called Knight Capital, a US investment prime broker, they were one of the interfaces for other companies to the exchange, did a release of their software, tested it and concluded that it was really brilliant, left it running in production, and about 45 minutes later, they lost $460 million and they had to bankrupt the company. And during those 45 minutes, they made more than $6 billion of trades that nobody requested, because they were retrying and retrying and retrying and retrying trades that should not be retried. So, you know, they proved that if you request a trade, it goes through and it gets executed, but did anything else happen? Nobody knows. And these kind of, you know, additional retries were happening. So by the time they spotted the problem, it took them 45 minutes to spot the problem. By the time they spotted the problem, it was all over. And that's kind of the big problem of these things where, you know, and they were in control of their infrastructure. Now imagine not being in control of the infrastructure and being in that situation, how scary that is. So that's kind of part of the larger problem, but I think approaching logging and changing how we approach logging is something that's testable. Getting testers involved in, I would expect this thing to be logged. I would expect these things to tell me what happened, and kind of creating acceptance criteria at that level as well helps us achieve these things. Now, kind of logging all these things, monitoring all these things is really, really interesting from a perspective of testing in production, but it also opens up some amazing new opportunities. The company I mentioned, we get an opportunity to kind of speed up the testing because maybe we no longer need to run all the tests all the time because we are protecting against risk in some other ways. As long as we have small releases, we can spot small problems. We don't have to kind of get this long testing process. The other thing we can start doing is much, much safer deployments. If we take the opposite of what happened to Knight Capital, and we say, well, you know, this is how we monitor logs, and then we deploy, and then if something unexpected is happening in those logs, we can start reversing that before anybody starts reporting a big business problem. We can have much, much safer deployments. And kind of, we can start opening up completely new types of insights that people didn't even know before or were not able to test. What I mean by that is things that were usually horribly expensive to test, like performance testing on a production equivalent. Usually, people that have kind of a big environment, they can do a bit of performance testing on, you know, a scaled-down version or a kind of replica, but replicas cost a lot, and you never really know whether you've concluded the right cases for performance testing because it's not the actual users doing, it's not the actual user workflow, it's some kind of simulation. When we deploy this thing and we have good monitors, we can monitor for performance very actively there if we have acceptance criteria for that. So one of the things that's really, really becoming interesting if we look at the cloud deployments is on AWS now you can use not just an API marketplace, but you can use a deployment API as well. And completely built in, they started offering a few months ago this thing called gradual deployments, where you can just tell it literally with a line of code in your deployment script, hey, on this new version, I want you to deploy it like this. So give me 10% of traffic every 1 minute and monitor for problems. And you need to kind of tell it what kind of monitoring to do, but then it's completely automated. It's like just give me 10%, and if something's unexpected, just kill the new version and just send everybody to the old version. And because this whole infrastructure is in the cloud, the traffic is coming to it anyway. So this thing opens up an incredibly, incredibly interesting way of kind of testing stuff in production. Like they have lots of these different types, like give me 1% every hour, give me, you know, and start increasing it linearly, start increasing it differently, and they have lots of ways of shifting the traffic between the two versions of the application. But this is something that only companies of Amazon, Google, and Facebook scale were able to do 5 years ago. Now you can do it for free. Anybody can do this for free if they're deploying on the cloud. And this becomes really, really important then to kind of define what we mean by something wrong happened. Because then it's up to you. Then it's up to the kind of testers to figure out what is the criteria for, hey, this is wrong. You know, and you can set up things like, well, I'm going to send 10% of the traffic to this app, and I'm going to compare the number of sales. If people are buying less on the new version than on the old version, just kind of kill the new version, keep the old version running. Or you can say, you know, are people opening the same amount of pages? Are the pages loading quickly enough? You know, but this is where I think starting to describe this criteria for monitoring in production also lets us do much, much better deployments. The other thing that we can start doing is kind of investigating what are the users actually doing. There's a tool called Hotjar that will record actual user sessions. And you can do regression testing on that. You can see that kind of people's mouse moved like this. And then you can deploy a new version of the application, and then it says, well, you know, in average, people's mouse moves like this. And you can say, well, this is a behavior change. This is, well, is it good, is it bad? Is it going in the right direction? And you can then inspect all these things. And that's another brilliant, brilliant opportunity that I think we can now start having, and we can start describing quality and testing from this perspective as well. So that's pretty much it. I'll leave some time for questions. And again, I've written about some of these things in Humans versus Computers. You can find more information on that. But thank you very much. Does anybody have any questions? Thank you.